Here we go for Algebra 2A. This is for section 3-1, which is about graphing and writing inequalities. And I'm going to start right off the bat just with an example problem. We'll get right into it. So let's say that you need at least $10 to go see a movie at the theater. Maybe it's $10 to buy the ticket, but then who knows, maybe you want to buy some snacks, you want some popcorn or a drink or some candy or something like that, but you know you need at least $10 to buy the ticket. So we're going to do a few things with this. We're going to define a variable, a number that we maybe do or do not know the value of. We're going to show possible values, possible numbers that work on a graph, and then we're also going to write an inequality. And we can actually do these in any order. There's not necessarily one thing we have to do first, but I'm actually first going to go and translate here for this problem, just to help us understand the problem a little bit better. So here when it says at least $10, this is one that I know a lot of students will sometimes get confused with. What does that mean, at least $10? And if I rephrase this, another way I could say at least $10 is I could say $10 or more. Okay, so to understand that, and you're going to see this a lot, especially in this class, at least $10 or at least some number, it means that number or more. In this case, $10 is the least. $10 is the smallest amount we could have. So it doesn't have to be $10, but $10 is the smallest. So if it's not $10, it has to be more than $10. So now what I'm actually going to do is I'm going to take a look at the graph. I'm going to look at some possible values for how much money we could have here to be able to go to the movie. So the first number I'm going to look at is 10 itself. So right here, so $10. So if I had exactly $10, would I be able to go see a movie? And in this situation, the answer would be yes, because that'll get us the ticket. We can buy the ticket. We won't have any money for snacks, but that's okay. We can still go see the movie. So 10 works. I'm going to put a green check mark for this. Okay, so $10, that would work. That would be what we would call a solution to this problem. $10 works. $10 would solve the problem of us being able to go see the movie. But I want to try another number. So maybe I want to think about what if it's not $10? It could be more than $10 or it could be less than $10. So what if I look at over here on the left side, if I look at $8 and I say, okay, so what if I had $8? Would that work? Would I be able to go see the movie? Well, in this case, no, I wouldn't be able to go see the movie because I don't even have enough money to buy a ticket. So $8 is not the solution. So for this one, I'm going to put a red X here. So that is not a solution. That does not work. I wouldn't be able to go see the movie there. What if I try a number on the other side? What if I try 12? Whoops, and let's make that in black. There we go. What if I try $12? Would that be enough so that I could at least go see the movie? And again, if you go back up here, I need $10 for the movie ticket. So if I have $12, I can buy my movie ticket and I'll have a couple of dollars left over. So maybe I could buy a snack, a cheaper snack, something like that. So for this situation, $12 does work. That is a solution. So that's what I'd have there. Now, obviously, there are a lot of other numbers we could check here. But what I like to do, since 10 is the number that's given to us, I call this the reference number. So I like to check the reference number, 10 in this case, and then I like to check at least one number to the left of it on the number line. So I did that with 8. I could have done it with 9. I could have done it with 6 or 5 or anything, 0. But check something to the left and then check something to the right. So again, I did 12 on the right. I could have done 11. I could have done 13. If I would have had more room, I could have done bigger numbers. So in order for me to show possible values, I don't want to have to tell somebody like, well, hey, how much money could you have? Well, you could have $10, or you could have $11, or $12, or $13, or $14, or $15, or $16. I could go on for a long time. Instead of trying to tell you all the dollar amounts, it might be easier, just to show you on a graph, the possible amounts there. So that's what the graph does, is it gives us a visual. We don't have to tell you all the possible numbers, but it shows the possible numbers. So I mentioned before that 10 being the number that's given to us here, that is what I call the reference number. So what we do with that on the graph is we put a dot, a little circle at that number. And in this case, since we said the reference number 10 works, we do what's called a closed dot. We fill the dot in, we fill the circle in. Sometimes it might be that the 10 won't work. Even though it's given as a reference number, it might not work. So in that case, we would do what's called an open dot. We would draw a circle but not fill it in. And we'll do an example of that a little bit later here. And then to show that the solutions, besides 10, the other solutions are to the right, like 11, 12, 13, and it keeps going forever to the right. What we do is we usually point an arrow, or we shade the line in that direction, in kind of a heavy shaded on the number line here. And I'll show you what that looks like. So something like that, where we have just really indicates, hey, the possible solutions are over here, they're on the right side. Okay. So that's making the graph. Next we will define the variable and we will write the inequality. So what I'm going to start with here is instead of actually using a variable, I'm going to use a number here. So I'm going to use the 12 to compare it with that reference number of 10. So I'm going to write the 12 and the 10, and then I'm going to think about what inequality symbol goes between them. So there's the 12 and the 10, and now if I say to myself, okay, I want to put one of those inequality symbols in there. If you remember the inequality symbols, there's 4 basic inequality symbols. So there you go, if you remember those inequality symbols: less than, greater than, less than or equal to, greater than or equal to. And a lot of people learn the inequalities like it's a hungry mouth. It has 2 numbers to choose between, and it's hungry, so it wants to eat the bigger number. So using 12 and 10 as an example, I know 12 is the bigger number, so my hungry mouth wants to eat the 12. This helps me because now when I want to use a variable, because like I remember it didn't have to be 12, it could be 11 or 12 or 13, so this number 12 could change. The 10 is going to stay at 10 because that's my reference number, but now what I'm going to do is I'm going to put in a variable instead of the 12, but I'm going to keep that inequality symbol. So there we go. So this is the inequality that I've got. Now, last thing, notice that I put the or equal to. Since 10 works, 10 is a solution, it could be equal to 10. It doesn't have to be strictly greater than 10. It could be equal to. But this is my inequality right here. So let's put that in a box. So that's the inequality that we have for our answer. Now, we've done, let's see here, we have done the graph, we've got that, we've now written the inequality, we've got that. The only thing left for us to do is to define the variable. So when somebody else comes along and they look at this, if all they had was my inequality, d is greater than or equal to 10, or all they had was my graph or something like that, but they see this variable d and they go, what is d? What does d represent? That's what defining the variable is. And again, you can do these 3 things in any order that you want to. You can define the variable first if you want, then make the graph, then write the inequality. The order that you do these things doesn't matter. But now that I have that variable d, and I go, okay, so what does d represent here? Well, d represents the money that we have. So there we go. D represents the money you have in dollars. Okay. So that is the last part of this. So we've got that as part of our answer, we've got our graph, and we could even just take that part of the graph, that's all we need. Okay, and that's everything we can do with this. So here are 4 inequalities with the inequality written 2 different ways and then a graph given. The only thing we're missing is a definition for the variable, but that's usually more for a story problem. So one thing I want you to notice here is, first of all, how the inequality can be rewritten. So if we look at the one on the top left here, we did this example, we used D instead of X, but we did this story about you need at least $10 for the movies. But what I want you to notice here is that we can put X on the left, and then we have x is greater than or equal to 10. But if we want, some people like to put x on the right side, and that's okay. But notice what happens here is that this inequality flips. Here it's x is greater than or equal to 10. Here it's 10 is less than or equal to x. And these mean the same thing. I like to give the example. It's like if I say, I am taller than you, it means the same thing if I rephrase that and say, you are shorter than me. Okay, those mean the same thing. They have the same meaning, it's just rephrased. So these inequalities here, x is greater than or equal to 10, 10 is less than or equal to x, it means the same thing. Every single time when we're doing that, the hungry mouth is still following the same number. So in this example down at the bottom left, x is the bigger number, the hungry mouth wants to eat x. Here, x is the smaller number. So if we flip it around, the hungry mouth wants to eat the 10, whether the 10 is on the right side or the left side. And here again, x is the smaller number, whichever side we have it on. Down here on the bottom, what we have is what I call the strictly greater or strictly less. Because your variable, whatever you're talking about, cannot be equal. Now there's different situations where that might come up, but notice here when it's not equal to how we have what's called this open dot. We have the circle at 10, 10 is still my reference number, but it's not filled in. So that shows that 10, even though it's the reference number, even though it's what we're comparing our variable to, it is not okay for the variable to equal 10. 10 is not a solution. Anything maybe greater than 10 here or anything less than 10 over here works, but 10 itself does not work. So you may want to take a moment to compare these four graphs. They're all very similar in their inequalities. They're all very similar in their graphs. 10 is the reference number every time, but some differences is the direction that we shade or point the arrow, and then the type of dot that we have. And then the last thing I'll do in this video is warn you about negative numbers, because negative numbers are backwards. Negative numbers can be difficult, negative numbers are backwards. So if we imagine our number line and if we put 0 in the middle, then we have the positive numbers to the right of 0. Typically this is the standard way to do it. And then the negative numbers are to the left of 0. And if you do your number line this way, then wherever you are, the bigger numbers are to the right and the smaller numbers are to the left. So to show you how these negative numbers go backwards, let's take a look here. So 4, if we look at 4 and 6 and we compare those, we know that 4 is less than 6. The hungry mouth wants to eat 6. And if I'm looking at 4 right here and 6 right here, I go 6 is further to the right, that's the bigger number. 4 is further to the left, 4 is the smaller number. But if I do this with negatives, you might be tempted to say that negative 4 is less than negative 6, but you would be wrong. If we look here, since negative 4 is right here and negative 6 is right here, I go, ooh, so negative 6 is actually further to the left. It is smaller. Negative 4 is greater. So our inequality needs to go the other way. It wants to eat the negative 4. So you've got to remember that. Negatives are backwards. That's one of the trickiest things about these inequalities. Okay. To help you remember, like how can you remember besides just knowing your number line? Smaller numbers are on the left, bigger numbers are on the right. How else could you remember this? We live in Minnesota. Right now as I'm making this video, it is a cold day outside. We're in the negatives, I think. So if you think about temperature, a negative number is like a negative temperature below 0. The colder the temperature is, the smaller that number is. The warmer the temperature is, the bigger that number is. Okay, so coming back here, I could say, well, 4 degrees is colder than 6 degrees, and 4 degrees below 0 is warmer than 6 degrees below 0. One more way, some of you know that with negatives, I often like to talk about money. So you could think about, negatives as you owe money. So here to do this example again, 4 versus 6, they're positive, positive 4, positive 6. It's the comparison of having $4 versus having $6. And so my hungry mouth, having to choose between those, would rather have $6. Would rather have $6 instead of having $4. having $6 is better financially. If we come down here to the -4 and the -6, that's like owing $4 versus owing $6. Now, if you have to choose between those two, it would be better to owe $4 instead of owing $6. So whatever helps you, if you can just remember that negatives are backwards, or you want to think about temperature, or you want to think about those negatives as owing money, whatever you need to do, right? But there you go. So that's the basics of these inequalities, graphing them, writing them, defining variables from a word problem.